Because a lot of students had trouble with this problem in the lecture questions, I wanted to post a solution to question 1, and then I'm going to make another video for the solution to question 2. But in this one, you're asked to assume that the graph provided on the grid here is the graph of a basic function y equals f of x. Oops. Sorry. What I meant to do is put an F here to label this graph. We're supposed to use that graph and then our knowledge of transformations to obtain the graph of f of x plus 2 minus 3. So once we've graphed our basic function, which that's done for us, we need to evaluate, okay, what transformations need to occur to obtain the graph of this function. So the plus 2 inside of the parentheses here, let me make that clearer. Because it's inside of the parentheses, it's inside of the function, or another way to look at it, the plus 2 is directly affecting the x. This is going to result in a horizontal shift in the graph. And the horizontal shifts typically do the opposite of what you might think at first. So plus 2 actually goes back 2 units. It goes left 2. So this plus 2 inside of the function f tells us to shift the graph left 2 units. Now the minus 3 outside of the function f, when we add or subtract a number outside of the function, or outside of the basic function, I should say, that results in a vertical shift in the graph. And so minus 3, that would shift the graph down 3 units. So to draw the graph of this new function, what we have to do is go point by point, shifting the important points on this graph left 2 and down 3. So starting here with this point, if I shift it left 2 and then down 1, 2, 3, it's going to land here. So I'm going to plot the new point right here. 2, down 3, lands right here. Okay. And I don't have my preferred stylus right here, which is why the writing is going to be a bit sloppy. Apologize for that. Okay, so this point, go left 2 and down 1, 2, 3. So this point shifts to this position here. Okay, and I'll go ahead and connect those dots. So what I've drawn right there is the new line segment. After you take this line segment, move the whole thing left 2, down 3. You get this line segment here. I'm going to move this point next, so it goes left 2, that's going to move it to the y-axis, and then down 3. It's going to land right here. Okay. Another point, move this point right here, left 2 and down 1, 2, 3. It's going to land right here. Left 2, down 3, lands here. And I'll connect those dots. And so I'm sorry it looks a bit sloppy, but that graph in red there is what you would get. It should have the same basic shape as our starting graph, but the whole thing is shifted left 2 and then down 3. And this is our resulting graph, if it weren't so darn ugly there. So that graph right there. Okay, let's do the same thing to function b over here. So again, we have something going on inside of the function f of x. So that's going to be a horizontal shift. Minus 1 shifts the graph right 1 unit. Now the negative 2 out front, that does trip people up a little more often. So when it's negative 2 multiplied by the parent function f. So when you have something like that, when you have a number times your original function, that's going to stretch the graph. The fact that it's negative will reflect it across the x-axis. But I'll just take that all as one transformation. I can transform the graph by multiplying, oh geez, yeah, it's going to be hard for me to write with this. So I'll abbreviate. Multiply the y-coordinates. Try that again. By negative 2. All right, so we're going to multiply all the y-coordinates by negative 2. That'll account for both a reflection across the x-axis and a vertical stretch. Okay, so I'm going to do that to these points, starting here. Okay, so I can shift right 1. That would land it here. The y-coordinate here is 0, so when I multiply by -2, it's still 0. So that point's going to land here. I'd do better just drawing with my finger here. I'll try this again. Right here. Okay. This point here goes right 1, multiply the y-coordinate by -2. So right now this y-coordinate is 2. When I multiply by -2, I'm going to get -4. So I'm going to keep the same horizontal position, but I'm going to move from y equals 2 to y equals -4 down here. Right, 1, 2, 3, 4, right here. And I'll go ahead and connect those dots. Okay, this point, again, I go right 1, multiply the y by -2, I get -4 again. And I'm going to get a new line segment right here. So this ends up going here. And one last point. So this point goes right 1. The y-coordinate right now is -2, so when I multiply by -2, I'm going to get +4 up here. So let's see, right 1, and then multiply by -2 lands here. And we end up with that line segment there. And I'm sorry, I have my window open. Okay, the plane's mostly gone. So overall, it should look like this graph moved right 1, was reflected across the x-axis and stretched by a factor of 2. And so that results in this blue graph here. But the key overall with problems like this is to take individual points on the original graph and apply your transformations. And just do that to enough of the points on the original graph where you can see the shape of your transformed graph, and then sketch it.